Hey guys, Mr. Farina here, working out some of the math questions for you guys on page 641, 642. So if you look at 13, it actually does it for us. It says, up here it says a plus 4 is less than 9, right? So what we have to do is, just like pretend this is an equal sign, we're going to solve and get the variable by itself. That's our first step, isolate the variable. So if I have a positive here, I'm going to have to do the opposite, which is negative. Right? So positive 4, I'm going to turn it to negative 4. I'm subtracting by 4 here. If I do it to this side of the equal sign, I have to do it to this side. So then I'm left with a. I bring my less than sign, and then 9 minus 4 equals 5. So let's look at number, and then we're going to go up here and graph it, right? So we have to remember that if there is a if it's less than, this is an open circle, right, or open dot. If it's less than or equal to, it would be a closed dot, right? You would shade this in. So that's something we have to think about when we are graphing these. So let's look at the next one, or I'm going to skip to number 15. So the equation says d plus 13. I'm just going to write it over here. D plus 13 is less than or greater than or equal to 22. So what I'm going to do first is isolate my variable. So what's the opposite of positive 13? It's going to be minus 13, right? And if I do it on this side of the equation, I have to do it to this side. So that means I need to do minus 13 here. So again, these cancel each other out. All I'm left with is d, right? I'm sorry, I don't have that much space, but I'm left with d. I bring my sign down, which was this, greater than or equal to. And whatever 22 minus 13 is, I need to borrow. This becomes 1, this becomes 12. 12 minus 3 is 9. 1 minus 1 is 0. So my answer is d is greater than or equal to 9. So if I go back to my graph here, what I would do is make my first line 9, because I know that's where I'm going to be. So we know over here would be 10, over here would be 8, right? I'm getting a little bit sloppy. Let me see if I can actually move this stuff around. One sec, guys. I couldn't really move my stuff around, but I have d is greater than or equal to 9, right? After solving it, hopefully you guys can show your work like I did. So I'm going to put my first line here and put 9. My next number would be 10, right? And the one before that would be 8. So now I have to graph. I'm at 9. I have to think. Let's pretend d is a number that's greater than or equal to 9. That means d, think of a number that's greater than or equal to 9. Well, let's say 10. Well, 10 is on the right? So I know that my line is going to go this way. And now I have to think, is this an open dot or closed dot? Well, since I have the equal to sign down here, that means I need to close my dot. So this is a closed dot going to the right. That's how we do this. So we are going to do the same thing for number 17. We have g over 2. So I'm going to rewrite my equation. G over 2 is less than 6, right? Now, how do I isolate my variable? What's the opposite of g divided by 2? Well, that would be multiplied by 2's, right? So I'm going to multiply by 2. And when I do that, these cancel each other out. And I have to do it to this side too. Oops. So that's, that was supposed to be a 2. Doesn't really look like 1, so let me fix that. Again, I'm multiplying by 2. So let me do that. So now all I'm left with is g, my less than sign, and 6 times 2 is 12, right? So again, I just have to go over there and graph it now. Now right off the bat, I don't have my inequality doesn't have an equal to sign, so I know it's going to be an open dot. So that means I'm going to go over here, and I'm going to graph on my line again, over here. So let's make the middle point 12, because that's where we're going to start, right? Let me use a different color, so in case it gets a little confusing. So this is 12. One number that's greater than 12 is 13. One that's less is 11, right? So I'm going to have my dot here. Again, I said it's going to be open because there isn't an equal to sign, right? If it looked like this, I would have to do a close dot, but it doesn't. It looks just like this, no equal to sign. So that means it's an open dot, and now think, it says G is less than 12, right? Over here, G is less than 12. So if G is less than 12, what's the number that's less than 12? I can think of, let's say 10. Where would 10 be? 10 would be over here. That means I don't want to go that way, right? Because 12, I'm sorry, so we're gonna go that way. G is less than 12, which means the line's gonna go this way. That means G can be any of these numbers, all the numbers that are less than 12. And there we go. That's how we solve this one. Alright, I'm just going to start you guys off on number 16 here. So we have the equation, which is, let me zoom in a little bit, 25t is less than or greater than 100, right? So what is the opposite of 25 times t? When a number is next to a variable, that means they're multiplying. So if I'm doing 25 times t, I need to do the opposite of times, which would be divided by, right? 25 divided by 25. I do it on this side, so that means I need to do it over here too. And then these will cancel each other out. I'll get t is less than or greater than, what's 100 divided by 25? Basically, how many quarters are there in 100? So that's going to be your answer, and it's up to you guys to graph it. Alright, number 19 says a community needs to raise at least $5,000 to build a new skateboarding park. They're selling backpacks for $25 each to raise the money. Write and solve an inequality to determine the minimum number of backpacks they need to sell in order to reach this goal. So first we got to look at some key information here. So some of the information, I'm going to get my highlighter here, it says they need to raise at least $5,000, right? So that's the minimum they need to raise. And we know that each backpack is going to cost $25. So we need to figure out, if I'm trying to figure out how many backpacks it's going to take to equal $5,000, well then I would just say 25 times a certain number of backpacks, right? So we're going to say 25 times, let's say B. And is it saying it equals 5,000? It isn't, right? It says at least. At least. That means that this has to be, let's see here. Well, it's saying that we're going to have $5,000, right? And that $5,000 is the max, the minimum number that we can get, right? Because that's at least. So that means, can this number be, I'm pointing, but you guys can't see me pointing. Can this number be bigger than $5,000? It can, right? Because it says at least. That means if they make $6,000 over here, they're still okay with it. So we're going to say at least would be this. Now, is 5,000 okay? Yes, it is, right? So that means 5,000, we're going to have to put in the equal sign there. So this is our equation. It's up to you guys to solve it. So think, we have 25 times b, right? How are you going to figure out how to solve that? What's the opposite of 25 times b? Alright, that's number 19. Number 20 says, a sales associate at a computer store receives a bonus of $100 for every computer he sells. He wants to make $2,500 in bonuses next month. Write and solve an inequality to find the minimum number of computers he must sell. The minimum number, the smallest number he can sell, if he wants to get to make $2,500 in bonuses. So, if he's making $100, and it says over here, if I'm highlighting in blue, for $100 for every computer he sells, well, how much money would he make if he sold 2? Let's first answer that. So, if he sold 2, he would get $200, right? If he sold 10, he would get $1,000. So we're trying to figure out how much it would be for him to get to 2,500. So our inequality, we know, is going to be 100 times the number of computers he sells, right? Let's call it C. And that's going to equal 2,500, right? But the only difference is we can't put an equal sign because we're talking inequalities here. And it says solve an inequality. Inequality means less than, greater than, right? One of those numbers. So it says to find the minimum number of computers he must sell. So what's the smallest amount of numbers he could sell? Alright, so we know that this number over here, 100 times C, 100 times C has to be equal to however many numbers, right? It's going to be to equal 2,500. So we're going to say this number over here, oops, we want to eat this number, right? Because we want it to equal at least 2,500. So again, we have 100C. What we're going to do then is do the opposite, which is divide by 100. And if I divide this by 100, I get that C equals 25, right? Or C is greater than 25. So the smallest number we can sell is 25, isn't it? And you know what? I think I made a mistake here because it wants to find the number, the minimum number, which means 25 is acceptable, right? Because he can sell 25 to make that $2,500 bonus, but if he sells 26, he'll get $2,600, which is okay too. But we just want to find the minimum number, so he must sell at least 25, right? That's what our answer would be for number 20. Alright, if you're looking at number 21, it's the same idea that we've been doing. You need to separate this. This is the opposite of plus 2 sevenths would be minus 2 sevenths, right? So I want to remind you guys that you need to, when you're adding and subtracting fractions, you need to have the same denominator. So figure that out for number 21. Same denominator. For number 22, you need to, let me erase some of this stuff here. You have 0.2g, right? Or 2/10 g. So that is times g. So what's the opposite of 0.2 times g? You would have to divide by 0.2. So if you divide both sides, you should get your answer. So it's just going back to some stuff you learned earlier in the year. Alright, we're moving to number 23 here. It says, which of the following inequalities have the solution shown on the number line? Select all that apply. So we have these options right here, right? So let me add a box right here so I can work real quick. Alright, so this first box, we have n plus 3 is less than 8, right? So then I need to get n by itself, so what I'm going to do is subtract by 3 on this side, subtract by 3 on this side. I'm left with, let's cancel each other out, I get n, oh, that's a terrible n. N is less than, what's 8 minus 3? Well, that would be 5. So now I look over here. So think of a number, because my n is less than 5, right? What's the number that's less than 5? Let's say 3. Isn't 3 less than 5? Sure. So over here, I'm going back to my number line here. A number would be, let's say 3. Is my arrow shaded in this way? Is it pointing to one number that's less than 5? It isn't, right? These numbers are all greater than 5. So that means that this is not a choice. I wouldn't select this one. You can do the same thing for the next ones. Alright, the last one I'm going to work out with you guys is number 29. And if we look at 29, it is just, this is just spiral review because this is stuff that you guys have learned before. But we're going to do 13.2 times 5, right? Now I'm going to rewrite it this way. Notice I'm lining up with my last digit here. And what I'm going to do is first I'm going to say 5 times. So 5 times 2 equals 10. So I'm going to bring my 0 down here from the 10 and bring my 1 up here, right? Now I'm going to go 5 times 3, right? So 5 times 3 equals 15. And I have that 1 over there. I just add that 1, so it becomes 16. Add my 1 over here. Now I have 5 times 1, it's 5, plus the 1 is 6, right? That's all I got to do. Now I got to think about my decimal. There's one number to the right. So I need to make sure that there's one number to the right, so I'm going to move it right here. So I have 66.0, right? And if I have 66.0, that's the same as just 66. So that is my answer. Alright guys, that's my video for today. If you need help, please join a Zoom with one of your teachers to help you with the rest of these. Alright, good luck.